Welcome back to the Table Talk series where we're covering Chapter 14 of the NFPA 72, specifically the Visual Inspection Table and the Testing Table, which is 14.3.1 for visual and 14.4.3.2 for test. We're going to go over component number 2 of the series, and at the end, we'll have some test questions so you can test your knowledge to see how much you learned today. So component number 2 specifically goes over the control unit, or more commonly known as the fire panel, FACP, FACU, whatever acronym you use. So let's begin going over the document. So we have the NFPA 72, 2025 for the National Fire Alarm and Signaling Code. It's Chapter 14, Inspection, Testing, and Maintenance Tables. This is the educational field guide, and specifically we're going over again component number 2 of the series. And there are a total of 30 components in the testing and visual tables. So component number 2, again, table 14.3.1, which is the visual inspection table, and table 14.4.3.2, which is the testing table. Right? And specifically, this is all going to be again for the control unit. So we have our fire alarm control unit, again, the FACU stands for Fire Alarm Control Unit, or FACP stands for Fire Alarm Control Panel, common acronyms in the industry. So the Fire Alarm Control Unit, FACU, also commonly called the Fire Alarm Control Panel, FACP, is the central brain of the fire alarm system. It receives signals from all initiating devices, smoke detectors, pulse stations, heat detectors, processes those signals and transmits alarm, supervisory, and trouble conditions to occupants and the supervising station. NFPA 72, Chapter 14 requires both regular visual inspection, Table 14.3.1, and periodic functional testing, Table 14.4.3.2, of the control unit to verify the system is operating as designed. Inspection frequency depends on monitoring status. Control units not connected to a supervising station require weekly visual inspection by facility personnel. Control units connected to a supervising station, monitored systems, require annual visual inspection, since the supervising station provides continuous remote oversight. Functional testing under Table 14.4.3.2 is annual for all systems regardless of monitoring status. And down here in the 2025 edition, there's a new 14.1.6 saying testing and maintenance personnel are not required to evaluate the adequacy of the design of an existing previously approved system. The scope of inspection and testing is limited to verifying the system operates per its installed design, not re-evaluating that design. So basically, however the system was put in, you're inspecting as is. You're not trying to make changes to the system. If a change is being made, it's probably going to be written up as a deficiency. So we have our little kind of example of a fire alarm control unit right here. We have our system normal on our screen, the AC power on, all zones normal. We have our status LEDs, alarm, supervisory, trouble, and AC power. We have our function buttons, acknowledge, silence, and reset. We have our zone enunciator, so zone 1, it says normal, zone 2, floor 2 normal, zone 3 stairwell, zone 4 mechanical. And then we even have a fuse status where one of them is open. Fuse 1, okay, 2, okay, 3 open. So just kind of a little example of a fire panel kind of in its normal state. And that's the layout status indicator right there. So first, we will cover on our next section here, the NFPA 72 Table 14.3.1 visual inspection for the control unit. So again, 14.3.1 is the visual table. So this is the inspection, no testing required. Table 14.3.1 governs the visual, non-functional inspection of fire alarm system components. The inspector observes condition and status without operating or activating the system. Frequency depends on monitoring status. Weekly systems not connected to a supervising station unmonitored / local only systems, no remote oversight, so facility staff must check weekly. Annual, systems connected to a supervising station, monitor systems. The supervising station provides 24-hour continuous oversight. For, again, 14.1.6, 105 inspectors are not required to reevaluate the adequacy of a previously approved system design. So, if your fire panel is not monitored by supervising station, the on-site staff basically has to do weekly inspections of the panel just to make sure everything is, again, in normal condition. If it is monitored by a supervising station, then you do annual inspections. All right? So, first up, for the individual components, we have fuses. Right? So again, when you do your visual inspection, if it's not monitored, you'll do weekly inspections for fuses. And if it is monitored, you do annual inspection for fuses. Okay? So, visually inspect all fuses in the control unit. Verify each fuse is intact and that no fuse indicator shows an open or in parentheses blown condition. Fuse integrity is critical. A blown fuse can silently remove power from a supervised circuit without the system generating a trouble signal in all configurations. So you want to confirm all fuse indicators, LEDs, or visual windows show normal / intact status. Check for physical signs of heat damage, discoloration, or corrosion at fuse holders. Verify fuses are not bypassed or replaced with incorrect ratings. If a blown fuse is found, document as a deficiency. A blown fuse may indicate a wiring fault or device failure downstream. Do not replace fuses without investigating the root cause. Notify the qualified service technician and log the deficiency on the inspection report. Next, we have the interfaced equipment. And again, if your panel is not monitored, the on-site staff will have to do a weekly visual inspection. If it is monitored, then you do an annual visual inspection. Okay? So, visually verify that all equipment interfaced with the control unit appears to be in normal operating condition. This is a visual status check only. Functional testing of interfaced equipment is covered under Table 14.4.3.2, which is the test table. The inspector looks for visible fault indicators, missing or disconnecting interface modules, or panel display messages indicating an interface system is in a trouble or supervisory state. Verify no interfaced equipment trouble or supervisory signals are displayed at the control unit panel. Confirm sprinkler system supervisory indicators, tamper/water flow modules, show normal condition at the panel. Confirm HVAC interface modules, door holders, relays, and elevator recall modules are present and show no fault indication. Verify all interface modules and relay cards are properly seated in the control unit and physically undamaged. Confirm no open circuit or short circuit trouble signals are present relating to interface system wiring. So all the different system types that report to your panel, again, you're just doing a visual inspection. So visual versus functional. The Table 14.3.1 inspection for interface equipment is purely observational. The inspector reads the panel display and visually examines modules. Actual operation of interface equipment, e.g. verifying the HVAC shutdowns, elevator recalls to ground, is a functional test and belongs to Table 14.4.3.2. So it's making sure you distinguish between your visual inspection and your testing. All right, next. Lamps and LEDs. Again, if the system's unmonitored, you're going to visually inspect weekly. If the system is monitored, you're going to visually inspect annually. So, verify that all lamp and LED indicators on the control unit are functioning and displaying the correct status for normal operating conditions. On a system in normal condition, the AC power/normal indicator should be illuminated, typically green. Alarm, supervisory, and trouble LEDs should not be lit during normal operation. LED status indicator guide, expected state during normal inspection. So on your left, you have a normal state inspection. Then on your right, you have deficiencies. So normal condition, only AC normal and battery charge LEDs illuminated, all alarm, supervisory, and trouble LEDs off. You don't always have this battery charge one on a panel, but you do always have a AC normal LED on. And then deficiency conditions. Any of these findings must be documented. Active trouble or alarm LEDs during normal operation require immediate follow-up. So if you have a trouble on your panel, or God forbid an alarm on your panel, you need to follow up with that. You need to troubleshoot. All right, next, primary power supply. So again, if your system's unmonitored, your on-site staff does this weekly, a visual inspection. And if it is monitored, it's annual. So verify that the primary AC power supply is present and that the panel's AC power indicator is illuminated. This is a visual status check only. Do not disconnect or manipulate power during an inspection. The functional disconnect test is performed under table 14.4.3.2. So AC power, normal/green LED is illuminated on the panel. No AC power loss trouble signal is active on the panel display. Panel is not operating from secondary power under normal conditions. No visible damage to the power supply area of the control unit cabinet. So you're just visually inspecting a power supply. And last but not least, for our visual inspection, we have trouble signals. Again, weekly for unmonitored, except this time it's semi-annual for monitored. So all the other conditions were annual if it was monitored. But for trouble signals, you're going to, even if it's monitored, you're going to inspect semi-annually. So confirm the control unit is in normal operating condition with no active trouble signals. The panel display should show no open circuits, ground faults, device failures, or supervisory conditions. Any active trouble signal not associated with a known authorized impairment must be documented and reported immediately. So, no trouble LED or audible tone active on the panel. Display reads system normal or equivalent. It could say anything, just a normal status for the panel manufacturer. No impairments are present that the building owner has not been notified of in writing. Any previously noted trouble conditions have been resolved or are still under an active written impairment notice. So if the building owner knows about it, it's already documented, and you just make sure that they know about it. It's fine. You don't have to do anything. But if they don't know about it, you make sure you do your due diligence and inform them. So that was the 14.3.1 inspection table. So now we're moving to table 14.4.3.2, which is the testing table, still for the control unit. So we did the visual table. Now we're doing the testing table. So this is functional testing. It's qualified personnel required. So it got to be a technician. So table 14.4.3.2 requires functional testing of the control unit and all its subcomponents. Testing involves operating the equipment to verify correct functional response and is required annually for all systems, regardless of monitoring status. All testing shall be performed by qualified personnel. Prior to testing, all affected parties, occupants, monitoring company, and building owner shall be notified per 14.2.4.1 and per 14.1.6, 2025. Testing personnel are not required to evaluate design adequacy for a previously approved existing system. So, first, again, we're going through our functions. So we do this on an annual. So again, 14.4.3.2. So operate or cause to operate all input-output functions of the control unit to verify correct system response. This verifies the panel correctly identifies, processes, and enunciates each signal type and transmits each to the supervising station. So, alarm signals verify correct receipt, display, an audible/visual enunciation at the panel. Supervisory signals. Verify correct receipt of an enunciation distinct from alarm signals, so they shouldn't be the same. Trouble signals. Verify correct receipt, audible tone, and visual indication. Verify each signal type is correctly transmitted to the supervising station, off-premises monitoring. Verify correct zone/device identification is displayed for each signal. Verify, acknowledge, silence, and reset functions operate correctly per manufacturer design. Opens or open circuits. Create an open circuit condition on an initiating device circuit, IDC, or signaling line circuit, SLC, by disconnecting a device or wire. Verify the FACU generates a trouble signal, identifies the correct zone or address, and transmits the trouble to the supervising station. Restore the circuit and verify the trouble. So basically remove a wire from like a smoke detector, a pull station, a heat detector, a flow switch, something like that, something that's going to initiate a signal. And by having it open, the panel will tell you that it's open, right? So you want your panel to tell you that a wire is disconnected somewhere, essentially. Ground faults. Introduce a ground fault on a circuit by connecting a grounded wire to one conductor. Verify the FACU detects the ground fault, generates a trouble signal identifying the affected circuit, and transmits it to the supervising station. Remove the fault and verify the trouble clears and the panel returns to normal. So ground fault is basically signal leakage or electricity leakage. So if the copper wires that run throughout your building that connect to devices, if they touch metal or they're exposed to metal, it's going to cause a ground fault condition. So you want to simulate a ground fault to make sure that your panel can correctly identify it. Next, you have loss of main power supervision. Verify the FACU supervises the primary AC power supply and generates a trouble signal upon loss of main power. Disconnect the primary AC power supply, confirm the panel enunciates an AC power loss trouble locally and transmits it to the supervising station. Restore power and verify the trouble clears. This verifies the supervision circuit itself is functional, separate from the primary power disconnect test under item 2E, which we're going to go over next or later. So basically you're just going to your breaker, your circuit breaker essentially, and you're turning off the power. So you want your primary power to turn off, you want your backup power to kick in, and you want your panel to identify, or I should say enunciate to you, that the main power has been turned off. So we have a little signal flow diagram. So we have the initiating device, pulsation detector, sends a signal, FACU, the panel processes and enunciate alarm/supervisory trouble. You have your alarm, notification appliances, you have your signal, supervising station, and then your emergency response. So each stage of this signal flow is verified during the functions test. The FACU receives the signal, correctly identifies and enunciates it locally, and transmits to the supervising station. Each signal type, alarm, supervisory, and trouble is verified separately. So whenever you send an alarm, it sends an alarm to the supervising station. Whenever you send a supervisory, it sends a supervisory to the station. And whenever you send a trouble, it sends a trouble to the supervising station. So it's going to make sure the correct signals get sent. So now fuses. So again, these are tested annual. Verify that all fuses in the control unit are of the correct type and rating as specified by the manufacturer. This goes beyond the visual status check in table 14.3.1. The technician must confirm ratings against manufacturer documentation and must functionally verify that the FACU supervises each fuse circuit. So you want to verify fuse amperage rating matches manufacturer's public specifications for each circuit. Confirm fuse type, fast blow versus slow blow, is correct per manufacturer's installation instruction. Verify no unauthorized substitutions, as in wrong rated fuse, bypassed fuse holder, wire jumper. Document each fuse rating tested and confirm it matches the system design documentation. Fuse supervision test. Pull or remove each fuse one at a time and verify the FACU immediately generates a trouble signal identifying the loss of that fused circuit. Confirm the trouble LED activates and the audible trouble tone sounds at the panel. Reinstall the fuse and verify the trouble signal clears and the panel returns to normal before proceeding to the next fuse. This test confirms the panel is actively supervising each fused circuit and will alert occupants and the monitoring station if a fuse opens during normal system operation. So, the whole point of this is just the panel supervising that fuse. So if that fuse blows, right, goes out, your panel should indicate to you that there's a problem, right? Older panels won't say specifically it's a fuse, it'll just have a trouble, right? So you have to investigate the panel to see what that trouble is. A more modern panel may tell you that it's a fuse issue or a NAC issue or a supervisor issue, whatever. It might be more precise in what it's saying, but basically you're making sure that the panel recognizes when a fuse is blown and it enunciates that to you. So, notify prior to fuse pull. Pulling a fuse will generate a trouble signal that will transmit to supervising station. Notify the monitoring company before beginning fuse supervision testing to prevent a false dispatch. Restore each fuse fully before pulling the next one. Interfaced equipment. Again, this is done annually. This is your functional test. So, operate or simulate the operation of all equipment interfaced with the fire alarm control unit. Verify the FACU correctly receives and displays signals from each interfaced system, and that all required output control functions activate properly upon receipt of the applicable signal type. Sprinkler water flow switches. Simulate water flow. Verify alarm signal received and displayed at FACU. Sprinkler supervisory devices, aka tamper switches. Operate tamper. Verify supervisory signal, not alarm, is received at FACU. So this should only send a supervisor, not an alarm. Door holders and magnetic door releases. Verify all held open doors release upon alarm activation at the FACU. HVAC/air handling units. Verify HVAC shuts down upon alarm signal from FACU output relay. Elevator recall. Verify elevators return to designated recall floor upon alarm signal. Fire suppression pre-action/special hazard systems. Verify pre-discharge alarm and abort control signals operate correctly. Test frequency for each interface system shall also comply with the applicable NFPA standard for that system, which is code 14.4.4.1. So if there's another code that applies to any of these, you would also follow it essentially. So this is all your device testing in here essentially. This is all your device testing. Make sure these interfaced equipments work. So your sprinkler system, your door holders, HVAC, elevator, everything, right? So coordination required. Many interfaced functions, elevator recall, HVAC shutdown, door release, affect building operations. Coordinate testing with the building owner, elevator contractor, and HVAC technician in advance. Ensure occupants are notified before activating any output function during testing. So I go to sites where sometimes they have an elevator tech on site and we do elevator testing, sometimes they don't, and they have their own keys on site. I go to sites where sometimes they have an HVAC technician there when I do shutdowns, and sometimes they don't, and the people on site do the shutdown and restart. So kind of just depends on your client, but it's basically warning you that you're going to be interfacing with other systems. Something could go wrong. It's often better, in my opinion, to coordinate with that building's contractor, but again, they might not have a contractor for that. You got to make sure you have that conversation with your client. Lamps and LEDs. Again, this is an annual test. So perform a lamp/LED test using the panel's built-in test function, if available, or by initiating a test alarm condition to verify all indicators illuminate as designed. Every LED and lamp visible to the operator must function correctly. Initiate the panel's lamp test function. Verify all LEDs and indicator lamps illuminate. Confirm the alarm LED illuminates red during a test alarm condition. Confirm the trouble LED illuminates typically yellow/amber during a trouble condition. Confirm the supervisory LED illuminates typically amber/orange during a supervisory condition. Confirm the AC normal LED green extinguishes when primary power is disconnected during primary power test. And then replace any burnt out or non-functional LEDs and retest before leaving the site. So other than the alarm red LED and the AC normal green LED, these other LEDs, the yellowish orangish ones, they could kind of be interchangeable. I've seen on panels. And also the power LED might not always extinguish. It might flash when the power's not on, but it's supposed to visually show you in some way that the power's been affected, is the point it's trying to make. Next, primary main power supply. Again, this is an annual test, and this is the full load test. So this one's a big deal. Functionally test the primary AC power supply by disconnecting the secondary or battery power supply and operating the system under full load, including all alarm notification appliances, to verify the primary power supply is properly sized and capable of powering the entire system at maximum demand. This test confirms the primary supply alone can sustain full system operation without the support of the secondary supply. Notify the supervising station and building occupants prior to beginning the test. Disconnect the secondary battery power supply from the FACU so the system will run on primary power only. Activate the system into full alarm. Operate all notification appliances simultaneously, horns, strobes, speakers, and any other connected alarm output devices. While all appliances are active, verify the primary AC power supply maintains system operation without voltage drop, reset, or failure at the FACU. Verify the FACU display remains stable and all outputs remain active under full load. Verify no nuisance trouble signals, brownouts, resets, or power faults occur during the full load condition. Deactivate the alarm and reconnect a secondary battery power supply. Verify the panel returns to normal operating condition and the battery charging circuit resumes. Pass criteria. With the secondary power supply disconnected, the primary AC supply sustains full system operation, including all alarm notification appliances, without any voltage drop. FACU reset, power fault, or loss of supervision. The system returns to full normal condition upon reconnection of the secondary power supply. Full alarm activation notice required. This is important. Activating all notification appliances simultaneously will be heard throughout the building and outside the building. It doesn't say, but sound travels far. Coordinate with the building owner to notify all occupants in advance. Engage the supervising station on a test signal before activating appliances to prevent a false emergency dispatch. So this is a good little tip. So, when you put a system on test, make sure you send a signal, not like an alarm signal, just like a trouble signal or something, just to make sure that your system is in fact on test, because you don't want to falsely dispatch the fire department. All right, now it's time for the knowledge check. Let's see how many of you are paying attention and you're actually trying to learn something here. So again, this is our component number 2, the control unit. NFPA 72 2025, tables 14.3.1, which is our visual inspection table, and 14.4.3.2, which is our testing table. Select the best answer for each question. Question number 1. During the annual fuse supervision test, what must a technician do to verify the FACU correctly supervises its fuses? Is it A, visually inspect each fuse for discoloration and verify the correct amperage rating? Is it B, pull each fuse individually and verify the FACU generates a trouble signal, then restore the fuse before moving to the next? Is it C, replace all fuses with new ones of the correct rating and verify the system returns to normal? Or is it D, disconnect the primary power supply and verify fuses remain intact under battery load? Take a guess. Let me know in the comments what you said or what you think it is. So question 2. During the annual functions test, you introduced an open circuit on an initiating device circuit. Which of the following correctly describes all 3 things the FACU must do to pass? Is it A, generate an alarm signal, activate notification appliances, and transmit to the supervising station? Is it B, generate a trouble signal, correctly identify the zone or address of the open, and transmit the trouble to the supervising station? Is it C, generate a supervisory signal, silence the audible tone, and log the event in the system history? Or is it D, generate a trouble signal, shut down the HVAC system, and illuminate the alarm melody? Which do you think it is? Take a guess and let me know in the comments. And last but not least, question number 3. During the primary power full load test, which power supply is disconnected first and what is being verified? Is it A, the primary AC supply is disconnected to verify the system transfers to battery backup without interruption? Is it B, both the primary and secondary supplies are disconnected simultaneously to verify the system fails safely? Is it C, the secondary battery supply is disconnected so the primary AC supply must sustain the entire system under full alarm load, including all notification appliances without voltage drop or failure? Or is it D, the secondary battery supply is disconnected to verify the battery charger activates automatically upon reconnection? Which do you think it is? Take a guess. Let me know in the comments. And that is the end of component number 2 of the series. So again, we went over the control unit, which is basically your main fire panel. And we covered our test and inspect tables, the 14.3.1, which is the visual inspection, and the 14.4.3.2, which is the test table. And there are, again, a total of about 30 components in the test and inspect tables. So we're going to have, hopefully, go through all the videos, all the component videos in this. So next would be component 3. So those of you watching, hopefully you can answer these questions. Like I said, let me know in the comments. And I will see you in the next video.